Most business cards are boring. Just a name, email address, and maybe a logo. So I wondered, what if I turned something as simple as a business card into an engineering project? It needs to be interactive, something people will remember. After a lot of designing and coding, this is what I ended up with. The first thing I needed to figure out was what this thing was actually gonna do. It needed to look alive. Eventually, I settled on an audio visualizer. The idea was pretty simple. Use a microphone to capture sound, an ESP32 to process it, and a matrix of LEDs to display the result. That gave me a clear direction for the hardware and something that would hopefully feel a little more interactive than a normal business card. The next step was turning it into an actual PCB. After finding all of the components, I started laying everything out in KiCad. I originally planned on using a common I2C mic, but for some reason, a lot of them were out of stock. So I went with this PDM microphone instead. As this is an audio visualizer, the LED matrix naturally became the main feature on the front of the board. I went with an 8x5 layout of individually addressable LEDs, which gives me 40 pixels total. It's not a lot of resolution, but it's enough to make recognizable motion and patterns. I chose WS2812 LEDs, which made the routing much simpler because they can all be controlled from a single data line. Other than that, the board just needs the ESP32, a 3.3 volt regulator, logic level shifter, USB-C port, and a few buttons. One thing I wanted from the beginning was for the back of the PCB to still feel like an actual business card. So instead of leaving it blank, I added QR codes linking to my portfolio and LinkedIn, along with my social media information. And with that, the design was complete. I sent everything to NextPCB for manufacturing and assembly. For this project, I used their full turnkey service. They took care of both PCB fabrication and component assembly. So instead of having to assemble over 100 components myself, the boards arrived fully assembled and ready to power on. If you're designing PCBs and want a manufacturing service that handles everything from prototypes to fully assembled boards, check out the link in the description. Once the boards arrived, it was time to finally test them. There's always that moment of uncertainty when you're powering on a custom PCB for the first time. Thankfully, everything came to life. Running a quick test showed the matrix worked and the mic detected sound. Of course, simply detecting sound isn't enough. The microphone outputs a consistently changing stream of values, so the first step was figuring out how to interpret those values. I wrote some test code to monitor the signal and get a feel for the range I was working with. Once I understood the data, I could start turning it into something visual. When a volume over a certain threshold is detected, a full row of LEDs lights up. Technically, it worked. The display reacted to sound exactly like I wanted, but visually, it wasn't very interesting. It looked more like a volume meter than an actual visualizer. Instead of only preserving the current audio level, I wanted the display to preserve a little bit of history. So I created this scrolling waveform. The result is a waveform that continuously moves across the board. You can actually see the audio evolving over time instead of just seeing the current volume level. At this point, I was happy with the results. And it did accomplish what I originally set out to build, but the more I looked at it, the more I felt like I was underusing the ESP32. That felt like a missed opportunity, so I started adding more features. The first new feature is a frequency spectrum analyzer. Instead of only measuring overall volume, it breaks the audio signal into multiple frequency bands and displays them independently across the matrix. Then I added a breathing animation that smoothly fades through different colors. This is a custom selectable solid color mode, and this is a scrolling text mode that lets messages move across the display like a tiny LED sign. Multiple modes means I need a way to actually control them. And since it's too late to add a button, the next best solution is to host a Wi-Fi network on the ESP32. When the board powers on, it creates an access point called audio card. Connect to it and you have access to the control panel. No need to download an app or pair Bluetooth. From there, all of the different modes appear as swipeable cards. The waveform visualizer, the spectrum analyzer, the the breathing animation, the solid color mode, and the scrolling text mode. Some modes also expose additional controls. For example, the color mode displays a color chooser, allowing the display to be changed to any color you want. The text mode provides a text box where messages can be sent directly to the board. Communication between the phone and ESP32 happens over WebSockets. This allows changes to happen instantly without refreshing the page. Now, all of this is super cool, but I don't want to carry a circuit board in my pocket all day. So I modeled and 3D printed a simple case that doubles as a stand. With the enclosure in place, the whole project finally felt complete. What started as a simple idea turned into something way more capable than I originally planned. But that's usually how these projects go. You solve one problem, then immediately find another one that's more interesting. And before long, you're way further down the rabbit hole than you expected. Still, I think it was definitely worth it. It's unique, it's interactive, and it's definitely a lot more memorable than a piece of cardstock with my email address on it. Subscribe if you liked this video, and don't forget to check out NextPCB for your next project.